Okay, so today we're going to take a look at two different things. One is a item system, just like how we did the weapon system in our previous tutorial. We're going to do an item system. Because this is a hybrid zombie shooter, it's going to have a little bit of survival element to it as well. So we want our player to be able to go and grab some food cans, some medicine, some bandages, maybe some quest items and stuff. And we want to be able to utilize that backpack that's on the back of the character and give them specific amount of slots in the backpack for them to hold. So on top of making the item system, we're also going to be doing our backpack component system as well. In the core folder where we have our weapon system, we're going to right click, create a new folder. And this is going to be for our item system. It's going to be a very simple item system. We're going to first create a structure. Name this as s_item_info. And let's open this up. And the first thing we're going to need is a name of the item. And this will be a type name. Next is going to be a static mesh. We're going to name this sm_item. Static mesh. SM stands for static mesh. And let's search for static mesh here. Object reference. Next, we want some sort of a type for the item. We want to define if this is a food item, if this is a medical item, or if this is a quest item. Whatever the case may be, we want to use an enumeration to take care of that. So go to your content drawer, right click, and create a new enumeration. This would be e_item type. Let's open this up and add in a couple lines here. First one is going to be a food. Second one is going to be medical. Third one is going to be a quest. And we're going to have one more that's for scrap. Let's close this up. In our item info, let's add that in. So here I'm going to add in item type. And this would be of type e_item type. The next variable, it would be healing amount. Now, not all of the item type is going to have an healing amount, but for the most part, the food and the medicine is going to have a healing amount to it. And if the quest item or the scrap doesn't really have any healing amount, we could always leave it at 0. Now, in this game, we're going to have a commerce system where there's going to be a currency system. So we do want to add in a value to our item. And this would be of type integer. So it'll be a whole number. This is good for now. Now I'm going to go ahead and close it. And let's go ahead and save all. Because of the currency system, I'm going to go back into my weapon system, S weapons, and I'm going to add a value here as well. So when the player sells this weapon or the item, they get some sort of an in-game currency back that they get to use at places to buy things. So let's go ahead and save all. Let's right click and create a new data table. And this would use the structure s_item_info and say OK. And then we're going to go ahead and name this as dt_item data. Let's go ahead and save all. And we're going to add just one line to get started. I'm going to go ahead and add a candy bar as the item, just so that we have at least one of them available. And the name is going to be Choco Bar, right? And we'll find a mesh for it momentarily. And the item type is going to be food. And the healing amount is going to be like 5 health points at a time. And the value is going to be like $1. Okay? That's all we're going to do for this Choco Bar. All right. So now that we have our weapon system and our item system ready, these are the things that's going to go into the player backpack. So let's go ahead and create a player backpack. So we're going to right click and create a new folder. And this would be our backpack_system. Let's go ahead and open this up. First, we're going to create a component, an actor component that's get attached to the main player and utilize this backpack system. So let's create the actor component and then name this BPC for blueprint component _ backpack. Let's go ahead and save all. And first thing I'm going to do is go to my third person folder, blueprints, open up my third person character, and go ahead and add this to my character. If I search for backpack, I should get the backpack. Compile and save. Now that gets initialized. I don't require the third person character at this time. So let's go ahead and open up our BPC backpack. The first thing that we're going to create is a new variable. And this would be our backpack underscore struct. Now this backpack struct needs to be of a type of a structure that's going to combine both the item info and the weapons info, so we can have both weapons and items in the same backpack. So let's go ahead and create that. In our content drawer, we're going to go ahead and create a new structure and name this s underscore backpack. Open this up, and we're only going to have two variables at this time. As we expand the system, we will keep adding more. The first one's going to be s underscore weapons info, and this would be of type our weapons info. And the second one is going to be s underscore items info, and this would be again our item info, s underscore item info. Let's go ahead and save it, and we can close this structure. We're not going to create a data table for that. We're just going to create that structure, and we're going to call that structure in here right now, s underscore backpack. And because we'll be holding more than one item, we want to change this single type to an array which can hold more than one. And here we're going to go ahead and create a new variable, and this would be our max bag slots. Now this is the maximum amount of slot that the bag can hold. And in the beginning, you want to make it like maybe 10 slots or 15 slots. And as the player progresses through the game and levels up or buys it from a merchant, you can try to give them a bag upgrade. So here I'm going to make this a type single, compile it first. And I'm going to add in, let's have the player start with 15 slots. That sounds like a reasonable number. And immediately I'm going to drag this maximum bag slots and our backpack struct off of event begin play. Let's get rid of this tick for now. And I'm going to drag off of this struct, and I'm going to say resize. And connect this to event begin play. And the size would be our max bag slots. So what this will do is it will automatically add slots to our array here. This is actually doing it through the code, and it's going to be doing it in runtime. So I don't have to manually go and set up one at a time. Now we can go ahead and save this. So now the struct is initialized with 15 slots. Now we need to add stuff to our backpack struct. So let me explain how this backpack struct works. Each array in a backpack struct has two members in it. If I open this index up, it has a weapons info and items info. Obviously, weapons info has all of the weapon details that we created in the previous tutorial. And the items info is going to have all of the items info. Now, when we add something to our backpack struct, and let's say this index 0, if we add something to this index, we want to add either the weapon info or the item info. We don't want to add both of them. So the player only has 15 total slots for them to manage between either storing weapons or storing items. So it adds a lot more character to the survival aspect of it. Now, how do we tell the game, or how do we tell this component that which one's weapons info, which one's items info? So we're going to go back to our structure and define that. So back in our backpack structure, we're going to create a new variable. This is going to be slot type. And the slot type, we want to create an enumeration for the slot type. So let's go ahead and create a new enumeration. And this would be e underscore slot types. And our slot type is going to be either or. For now, we have two, which is either going to be a weapon slot or it's going to be an item slot. So let's go ahead and close this out. And in our backpack, we're going to go ahead and create and select our slot type. So e slot types is going to be our type. And also we want to fill up that slot with some sort of a value, like a number, integer, when an item gets placed in that slot. For now, we're going to work on the weapons, which is always going to be quantity 1. And then when we do our items add to backpack, we're going to do stack size and all of that in just a moment. So I'm going to add in a new variable here, and I'm going to add in a slot quantity. And this would be of type integer. Let's go ahead and save that. And this slot quantity is going to just tell us is there any quantity in that specific slot. Like if I add in S weapons, that quantity will say 1 because we're going to add 1 weapon. And even if we add S items info, it's going to say there's 1 item in there. It's not going to give us the stack size, but it's going to tell us there is an item in there. This is what we're going to use to identify if that slot is empty or not. If the slot is empty, there should be the quantity should be 0. And if the slot is full, then the quantity should be 1. So let me show you how that works. First, we're going to create two functions. The first function is add to backpack, And then I'm going to make a dash and say weapons. When we call in the add to backpack function, we're going to either add in weapons or we're going to add in items. Items is going to have its own functionality to add to backpack because it's going to have a stack size, but the weapons will always be 1. So I'm going to go ahead and right click and then duplicate this function. And then I'm also going to name this as items. Compile and save. In our add to backpack weapons, I'm going to select the input and I'm going to go ahead and create a new input here. And this would be weapon info. And this would be of type s_weapons info. Now we have 15 different slots in the actual backpack at this time, and it's going to grow even further as the game progresses. So we want to find the next empty slot available, and we want to plug this weapon into that slot, whichever one is available. So for us to do that, we're going to go ahead and create a new function. And this would be find next available slot. That's how we're going to name it. I'm going to get my backpack struct here, get, and I'm going to do a for each loop. So it's going to go through each one of that 15 slots. And for each loop body, it's going to go through one slot at a time, and it's going to go through all 15 of them. I'm going to open this array element and I'm going to break it. And this is going to give me the slot quantity. And remember, if the slot is empty, we're going to have this slot quantity as 0. So we're going to go and check if the slot quantity is greater than 0. No, greater than 0. Add in a Boolean and then connect this to the loop body. Now, if the slot quantity is greater than 0, this is off of true. We don't want to do anything. We want to continue on with this code. Now, and if the slot quantity is not greater than 0, that means it's an empty slot. So we're going to go ahead and do a return node here. And we're going to drag this index and we're going to plug it into this return node. So we know this is the empty slot. So first I'm going to do some reroute just to keep it tidy. I'm going to name this as empty slot. And off of completed, we want to do another return node. And our empty slot, we're going to set this to -1. -1 in coding is usually used to state nil or nothing, because 0 is something in coding. 0, 1, and everything is something, but -1 is considered as like nil in coding language in the number. So we're going to set this to -1. And we also want to add in a failure state. So in my return node, I'm going to add in a new output, and I'm going to go ahead and put in a success, name the success, and make that a Boolean type. And off of this slot, we're going to say success, and this is going to be set to fail as we just failed. We failed to find a slot. So back in my add to backpack, I'm going to call in this find next available slot. And now I get my empty slot. If success is true, that means we have successfully found a slot. Then I'm going to go ahead and drag this backpack struct, say get, and we're going to go ahead and say set array element and mark this off of true. Only when we successfully find the slot, we're going to do the set array element. And if we don't find a slot because success has failed, then we're going to do another return node here. And this is going to have an output. And this is going to say again, success is going to be a fail here. We're just going to leave it as false. And this set array element. So I'm going to drag this empty slot onto the index here. So I know which index I'm going to add the weapon. And also the weapons info. I cannot directly plug into this array element because this array element, if I drag it and if I make it, you can see it has weapons info and the items info as well. So we only want to plug this directly into the weapons info. So I'm going to go ahead and drag off of this and say get weapon info. This node is the same as this node. Instead of dragging it across the map, I just decided to do a get. And again, we're going to now set up our slot type. A slot type is going to be a weapon slot. And then also our slot quantity is going to be 1. Now we can compile and we can save this. And after this, we're going to go ahead and return. And this return node is going to be success. So this basically tells the game we have successfully added the weapon to our backpack. Now for our add to backpack items. Now our items is going to have a stack size. So we need to add that to our actual item structure. So back in our item system, ItemsInfo, I'm going to add in a new variable. And this would be our max stack size. And this is going to be of type integer. Now, for those who are not aware, stack size is basically when you can have more than one of the same item in the same slot. Say, for example, if you have 20 cans of food. So you can choose to have 2 separate stacks of 10, or you could have 1 stack of 20 and so on. You determine what is going to be your maximum stack size, and then you will set it up in game. Now that we have our stack size set up, we're going to go ahead and in our backpack item, first we need our item info, and this would be of type s underscore item info. And next is going to be our quantity to add. So I'm going to say qty to add, and this would be an integer. This is basically how many pieces that you want to add to the stack. So first thing that we're going to do is we're going to run this off of a while loop. So it's best if we add one item at a time because we have stack size. We want to now find an existing stack and then add the items to that stack. And if we still have remaining items left, then we want to be able to create a new stack. For that, while loop works best, so we can go through it one by one and keep adding it until the stack becomes full. And then we will create a new stack if once the previous stack gets full, and then we will continue adding it. So while loop, as great as it is, it's a very dangerous thing to use. I have had so many bad experiences with while loop in other softwares that I have used before. And this could definitely create an infinite loop error. And Unreal does have a little bit of built-in check to make sure that if the while loop is not properly set up, it's going to throw an infinite loop error. So we have to give it a condition. So while this condition is true, the while loop is going to continuously keep running. And we want to be able to make this condition false when certain things does not really happen. First thing is when our quantity runs out to 0, we want to go ahead and stop the while loop. Now we don't want to add the quantity here directly. We want to make this quantity as a local variable. So in our local variable, I'm going to add in quantity-local. And here I'm going to go ahead and set. And the first thing that we're going to set before we start the loop is the quantity local, which is basically how much you want to add. And we're going to set up a condition saying while this quantity is greater than 0, and we want to give it a second condition. It's always a good idea to give it 2 conditions. And I'm going to do a second check. Again, I'm going to do this locally, and this is going to be success check. And this would be of type Boolean as well. And drag this. I'm going to drag off of this and say not Boolean. Yeah. So while the success is not true and the quantity local is greater than 0, so I'm going to connect this to the AND, the while loop can run. As soon as the success is set to true or the quantity local reaches 0, then this while loop should automatically stop. This is going to be our check. So now that we have our condition for the while loop, we're going to start with our code. First thing is we want to find a slot. We're going to find either a new slot, an empty slot where this item doesn't exist, or an existing slot that this item already exists. So let's go ahead and create a new function, and this would be named as find slot. And this find slot, we're going to have an input, and this would be our item info. Again, this would be of type s underscore item info. And we're going to get this backpack struct, and we're going to do a for each loop. And this is how we're able to go through each one of these items in here. And we're going to drag this array element and we're going to break it. And we're also going to, what we're going to do now is we're going to check if every single item in this backpack struct. And whenever the item info in that backpack struct of that specific index matches the item info that we just sent in, that is a slot with this item already existing, and we can check to see if the stack size is big, if the stack size is full or not. How that would work is you just take this array element, break it, and then we're going to drag this s item info, and we're going to break it even further, and then we're looking for the name of the item itself. Now we need to check to see if the name of this item that's within our backpack struct matches this item info. If it does, that means we found a slot with this item in there. So first I'm going to do is get item info, and then drag off of this and do a break. And then I'm going to get the name again. So I'm going to go ahead and drag off of this name here and say equal, and do an equal here. And then put a branch up top. And this branch I can connect it to the loop body, and then connect this here as such. Now we're checking to see if this item inside of this struct, it matches the item info that we're trying to add. So if the branch fires true right now, that means we found an item in the backpack that matches the item that we want to add. So once we find that item and we have a true, Now we need to check the stack size. What is the stack size of the item in our backpack, and what is the maximum stack size allowed for that item, and see if that actually matches. So to check it, it's pretty straightforward. We're going to drag our slot quantity here, and we're going to go ahead and say less than, it has to be less than, the maximum stack size. If the slot quantity is less than the maximum stack size, then again, we want to do a branch because this will give us a true or false. And this we need to connect it off of a true. We only want to do the stack size check if there is an existing item that matches our item that we want to add. If there's no existing item, then we don't want to do a stack size check here. And if the slot quantity is less than the actual maximum stack size, then off of true, we want to send in a return node. And this return node needs a couple things, a success node, and then check this in. And then also we want to know which index that item is sitting in. So in each loop, we need to find out which slot number, that's what the index is stating, which slot number in our backpack actually has that item. So we're going to drag this array index, and we're going to plug it into this return node just like this, and that'll create a new node there. Now that we have notified the index here, we also want to send in a failure state. Let's say it went through the entire loop and it did not find a matching item, then this completed will run. So off of this, we're going to go do a return node, and the array index, we're going to make it into -1. And the success, we're just going to leave it as blank, so indicating that it's a failure. Now back in our add to backpack items, in our while loop, first we're going to try to find the slot. And here, the item info is going to be the same item info, so I'm going to go ahead and plug in item info. Just like that. And off of success, I'm going to do a branch. And if it has successfully found the slot, we're going to do a add to stack. So we're going to say add to stack dash items. This is going to be for our items. And this is going to have a index input, which is going to tell us which specific part of the backpack or which slot in our backpack that we can add this item to. So I'm going to go ahead and put in an index of type integer. And then we're also going to have a quantity, and that will be of type integer as well. And this is pretty straightforward. We're going to get our backpack struct here, and we're going to get a reference to the index that we just sent in, and we're going to go ahead and break this backpack, and this is going to give me my slot quantity and also the items info and such. So first we need to take our existing slot quantity, which is this, and then add this new quantity to it. So I'm going to drag off of this and then say plus, and then add this new quantity here as such. And now we need to set this to our array element. So drag our backpack struct in here again. And I'm going to say set array element. This is what we're going to use. And the index is going to be this index here. So I can just drag off of this and say get index. And that will be that. And the item is going to be something that we need to make here. So let's go ahead and make our backpack. Let me move this out just so that we can have some room. The ItemsInfo is going to be plugged in here as such. And then the quantity is going to be plugged in here. And the slot type, we're going to make it into an item. Let me move this down here and then also move this guy down here. Sometimes it's absolutely crazy where all these wires are going. It's hard to maintain them, but you know, we do our best to try and keep it nice and clean as possible. This looks pretty good. So what we're doing is when we say add to stack, we're getting our current item from the backpack at that index that we just found in our find slot. And then we're getting the current slot quantity. If it is 0, then it's going to be just 0, and add this new quantity to it. So the total of that, we're getting the array element from our backpack and we're adding it, and then we're setting that to our backpack again. So if it was 1 in our backpack and we're adding 1, it's going to get that information 1 here and then add that 1. So this total quantity will be 2, and then it's going to go ahead and reset that element again. Now back in our add to backpack, off of true, this is when we have found our slot. We're going to add to stack our items. And I'm going to plug this index in here, just like that, so I can say which index that the stack needs to be updated with. And the quantity is always going to be 1. Remember, we're going through a while loop, so we want to go through the item one by one, and if the stack is available, then we want to add 1. If the stack is not available, then we want to go ahead and add it to a new stack. So that's why we want to add it one at a time. Once we add this item to the stack, then we want to get our local variable, which is our quantity local. And we want to go ahead and subtract, or we can say minus minus, and that'll give you this decrement integer. This will reduce this quantity local by exactly 1. Now here we're finding a slot that already has the item in there. And if it does, then we're going to go and add our item to that existing stack. Now, if there is no slot with our item already in there, which is our false here, then we want to go ahead and find the next available slot. So this is our next function that we want to run. We have already previously made this for our weapons, and we're going to reuse this. It's going to do the exact same thing. And off of success, we're going to connect our execution pin here. If it is success, that means it has found an empty slot. This is the index for it. Off of true, we want to now create a new function to create a new stack. So I'm going to create a new function and name this as create new stack, compile. And this create new stack, first of all, it requires the item info. And this would be of type S item info. Next is going to be the index. And this would be integer, compile. And this is pretty straightforward. We're going to get our backpack struct here. And we're going to set array element. Let me move this out a little bit. Drag off of this, and we're going to go ahead and say make backpack. And this item info is going to be connected to the S item info. The index will be connected directly to the index here and connect the execution pin just like that. And then the quantity will always be 1. Whenever we create a new stack, we want to start with 1 quantity, and we're going to keep adding 1 at a time. And the slot type, we want to make it into an item type. Compile and save. And that's all we need to do for creating a new stack. So back in our add to backpack items, we're going to go ahead and actually I'm going to put in create new stack dash items and plug this off of into true. Item info, I'm going to drag this and say get item info. And this is the same thing as what we have in the beginning here. That item info is the same thing. And the index would be the empty slot that we just found here. Once we create a new stack, we also want to return something. We want to return a success message or success boolean. So here we want to go success and make this of a type boolean. And then back here where we create new stack, we want to now do a branch, and we're going to go ahead and set that success there. Oh, and make sure you check this as true, or else it will fail. And then back to add to backpack here, we want to copy this quantity local and plug this in here. So we reduce 1 of our quantity local. And off of this fail where we cannot find the next slot, if fails, that means we have no more slot available. So our local variable where we have success here, we're going to go ahead and set this to fail. Actually, let's go ahead and change this name. It doesn't make any sense. We're going to say failed. Okay, that makes more sense. And set this to true. And we can also set off of our create new stack, we can also copy and paste this and then set this to failed. So as soon as this failed goes true, then this loop body is going to stop. And once all of this is completed, when the while loop actually stops because things have changed here, we're going to go ahead and do a return node here. And this is going to have our failed message, and then also our quantity remaining here, and this would be of type integer. We're going to take our quantity local and then plug this in here, and then failed, we're going to get failed, and then we're going to do a not boolean and plug it in here. The game just threw a weird error for this failed when I changed it from success to failed. So I just had to rename it to local failed. and then yeah, set it up just like that, and then it seems to like it now. Not exactly sure why that happened, but this is basically our function for adding the items to the backpack and also checking for the stacks. I think this is a good spot for us to stop. This is a quite long tutorial, but we did cover a lot of things. We covered our backpack function for adding weapons and also the items in a stack size and weapons as one each. So I think this is a good spot for us to stop, and we'll pick up on the next one.